بس من وين طالع؟
So, welcome to Project 1. Alright, so for this project, what you're going to do is write a program that is going to be a text-based database system, very old school. And it'll allow you, or your users, to take information from files that will contain things like information about students, about who was enrolled in what class, and what was their grade, and then finally the schedule of classes. So for example, way later, and after a ton of work on this project, you will be able to say, for example, load students, semicolon, and then you can say, for example, print students, semicolon, and it will list all of the information in that table. We see that it matches what we see here in the spec. All right. So there's a number of different commands you're going to be able to use with this database that you're going to write. They're going to allow someone to read information, write information, and search these tables. And they're described in the spec, and I won't go through them in detail here. But so far what I've showed you is, hey, there is a load command. Okay. So what's the point of all this? Well, the ultimate goal is we want to be able to allow our users to ask interesting questions. Not just who are our students, but we can also ask, these are very much like, if you've ever heard of SQL, the database system, it's very similar where I want to know, okay, I want to know the IDs and first name of any student whose last name is Chan. So I try that out, and I see, there's a Valerie and a Young Fan. All right, so we can ask queries like that. And we can also ask more interesting things. For example, ultimately we'll be able to say things like, okay, well, I'm going to load the enrolled table first. So this enrolled table says for each course control number and each ID, 3-digit IDs, it's a very small school, this is the grade someone got. So we'll be able to say, for example, give me the first name, last name, and grade of all students who are enrolled in course 21101, semicolon. And we find that, okay, well, here's Valerie and Young Fan again, and then there's two others. And all 4 of these students took the course here. So there's a lot going on here, actually, because your program ultimately is going to have to be smart enough to say, oh, someone wants these 3 columns. And what's even crazier, maybe, is that these 2 things are from the students table, and grade is from the enrolled table. So there'll be a lot of complexity there for that to work, right? So we print enrolled. This is where the grades were. We print students. Students. We see where the names came from, right? So, and there's actually even one more level of complexity to our queries, but I won't go into them right now because I want to focus only on the nuts and bolts of what I will call the first phase of Project 1. All right. So that's a brief intro to what you will ultimately be building, but let's start with just the things that we can understand for now, right? It's a long road to get here. So there is, I will note in the spec, a description of the order in which we suggest you do things. So here are numbers 1 through 6, and I'm going to call everything 1 through 6 the first phase of the project. And then eventually when you get to number 7, then it'll be conceptually a little different, right? So these are all the nuts and bolts, putting things in tables, and this will be the searching tables part of the assignment. So let's look at a little picture of all the classes you're going to build for this project. Let's see, do I still have a window? Yes, all right. So overall, here's the full picture of the things you're going to build for this project. There's a total of, let's see, we can count together, 10 classes. And every class I have here in green are classes that are provided for you for your use that you do not have to change. And then here are 5 classes that we provide that if you change just these 5 files, you will have a working solution. Now, of course, in the spirit of 61B, you're welcome to throw everything away and start totally from scratch. But if you use our skeleton, that's what you'll see. And I'll go through all these in a moment. And I'll mention one more thing. This number right here is the rough number of lines of code that's different between the skeleton and the reference solution. So in total, we changed about 200 lines of code, mostly in table. Okay, so I'm going to show only up through step 6, so I'll call this phase 1 of the project. This is the part that deals with reading and writing files and being able to print stuff out, and none of the selection or the searching, right? So whenever you download a set of files, you'll see that there is a so-called main class, just like we had with 2048, and it's going to be how the program kicks off and also provides the top-level control for everything. So main creates a command interpreter object. In fact, let's open up main. All right, here's main. We see that it has a variable here called command interpreter, and the command interpreter apparently takes information from a scanner. So this is the user typing an input, and the command interpreter does stuff with it. So main makes a command interpreter, and you'll do a lot of work here. And there's some starter code. So we do a lot of the annoying stuff for you, a lot of the tokenizing and the pattern matching. Because you can imagine it is a little tricky to be able to figure out, someone says this in a program, how do I get first name and how do I get last name? We saw that a little bit in homework 4, but it's a bit much for you to do from scratch. So we provide a lot of helper code that will make your life easier. So this is the incomplete command interpreter. You'll add somewhere around 50-ish lines of code to this, all right? At some point, right? But this is not where you're going to start, okay? But eventually, the command interpreter, what it's going to do is take information from the user, and it is going to make calls to a database, all right? So the command interpreter uses a tokenizer, which is a handy class for taking stuff that someone types in, turns it into commands for database, and makes database do all the hard work, right? So moving our way down, database is going to be a way to contain tables. So this class is going to be something like a collection, right? But a lot simpler. It will not extend implement collection. That would be horrible, because you know all those methods you have to write. Contains, all that stuff. But it is a convenient container for a bunch of tables. There's not a ton of work to do there. And then there's table. So table is going to be the heart of the project, or here, the brains, right? Okay, whichever metaphor you prefer. And what it does is it will do everything interesting, basically. So it's going to do the reading and writing from files, that is the .db files. It's going to do all the interesting operations, like searching for information. It's going to, well, I guess that's pretty much it, yes. So reading and writing database files and searching them. So it does all the main stuff. And then lastly, there's row. So a row is going to represent a single row of data, right? So you, when you start this project, may be tempted to try and use the command interpreter, or think about the command interpreter first, because after all, that's kind of what we did in 2048, right? We started doing some programming by bringing up the game and then inching our way to success, right? In this case, that is a losing strategy. In this case, I would much, much, much more strongly recommend that you work your way from the bottom up, so that you work with things that make sense first, right? We understand what a row is, and we can even build tests for how a row ought to operate. I mean, you don't know right now what a row is, but hey, that's what the spec's for, and that's what the skeleton code's for. So you'll start with row, and I would highly recommend that you try and write some tests for row that work just with row. Okay, so if you are tempted to try and use the command interpreter, right? So you figure, oh, I got a command interpreter. I know what I'll do. I'll have, so I'll start this thing up, and then I'll add myself a test row command or whatever. Please don't do that, right? It may seem very cool, but it will cause you a lot of headaches. Okay, JUnit's there for a reason. Ignore the command interpreter for now. That will come later, right? Okay, so let's look a little bit at the Roe class and talk about where you should start in terms of very concretely, not philosophically, but what is the thing that one ought to do. So of course, first, you should read the spec. So after reading these many words and comprehending what it is that you feel is most important to you at this moment, you will be able to begin working your way, I would say, up from the bottom. The truth. It's actually a program, not being beamed into my hard drive by my mind. Anyway, okay, so let's see. Yes, so the most important thing whenever you're getting started, once you start trying to write code, make sure you observe this advice, which gives you a rough picture of the order in which you should write things. So the first point is you should write tests at all times. Second is something that if you're using our skeleton has already been done for you, but if you're someone who wants to go totally from scratch, maybe you should do this first. I mean, you don't have to, but just a suggestion. Next, though, the first step that the most of you will be doing is implementing the Roe class. So in this case, what you're going to do is open up row.java. Does not exist. Oh, well, I'm in the solutions directory anyway, so glad it didn't work. All right, yes. All right, so here's row. This is the first class. One might write, because look, it says it here, and also it seems awfully close to the bottom of the list of dependencies. So looking at this, we see that we should implement everything but this one constructor. And I'll mention that real quick. Here it is in the code. This is a fairly complex idea that you don't need to worry about until you get to phase 2, where you start working on searching and selecting from tables. So you'll implement row. So I'm going to give a little demo of how one might do testing along the way as you write 3. So we look at row and we see that, okay, here's the constructor. There's no fill in or replace with solution or fix me. So I'm going to assume this is a reasonable thing for this constructor to do. So if we look up here, row is supposed to represent a single row of a database, and apparently Paul or someone, the Paul, I have no idea what that meant. Anyway, so here we have an array of strings. Okay, so how do we don't have to test this constructor, we're assuming it's good. So what's the first thing we need to do? Well, we shouldn't do that yet because that's confusing, so size seems like a good one. Okay, so kind of a not very challenging idea, figuring out the size here. There's only really one thing it could be, but just to demo how writing a test for this thing looks, let's try that out. So what I'm going to do is make up a new file. I'm going to call it basic tests, and it's going to be a class which tests our row class, and other things. Test basic functionality, including the row class. I can expand this later. Test basic functionality. All right, maybe I'll even move that up here. All right. Okay, so now I'm going to say public void test row. Could be one way of organizing things. I'll put a test flag, which it'll know what to do because of this. And then down here, I will have this whole big thing that we've seen many times before. So now I've got a framework, the boilerplate for our test. And now I can do something like, let's write one. So a row. A row is supposed to take a list of, or an array of strings as a constructor. So I will say row r equals new, row, new string, Josh is writing this test. Okay, true fact, whatever. All right, what came to mind? So that's a row. And then we will do an assert equals. All right, so we'll say assert equals r dot, what was it called? Size. R dot size, and presumably that should be 5. Except this should be expected than actual. Okay. So if we try running this thing, Java C basic tests, we get, something strange. Cannot access row. Class file contains wrong class. What does this mean? Okay, well, it means that the compiler is looking for a class named DB61B.row, but I only have row. So what's the problem? Well, the problem is, and maybe you would have run this into this in Lab 5 if you did the optional exercise, that the row class is part of this package, basic tests is not. So let's make it part of the package. Okay, so good thing to do. Now I say Java C basic tests, and it's still not working. Okay, so what's the deal now? Well, the problem is that it's saying, I don't know what a row is. Okay, that seems strange because row's right here. Well, let's try compiling row. Row won't even work. Okay, it says I don't know what a column is. So that's strange. Well, the problem is, if we compare this to how we actually, way at the beginning of this video, if I actually did it, compiled things, if I type make, we see that what the compiler does is something more complicated, right, than just type javac row.java. It does this much more complicated thing. I guess I should remind you, make files are not magic. All they do is run other commands. So in this case, it decides this is the command to run, and then there's this touch sentinel thing, which is explained in Lab 5. So here's javac-g. This says to compile the code so that the debugger knows what to do with it. Excellent unchecked says, look at the code and make sure that the programmer's not doing something crazy, and if they are, yell at them during compilation. There'll be something in the checklist. There's a couple little things you might do, but yeah, if you see some message that you've never seen before, it's because this right here is telling you part of your code is crazy. And we'll note that we now have this class path, which says look in all of these places, for example, for things like row and column and so forth, and then here's all the files that need to be compiled. And you'll notice that part of make, it already picked up on the fact that basic tests is in this folder, so we don't actually have to do anything to make it compile. So use make, please. If you try and use javac, it won't work. I mean, you can, if you want, do this whole thing manually. So if you want, you can keep copying and pasting this because you hate make, and it will work just the same. But if you don't want to have to do that, make is your jam. All right, so Java DB61B dot, now we can say basic tests, and we'll get test failed. Should be 5, but was 0. I'll mention one more thing that you can do if you don't want to have to keep typing Java DB61B dot basic tests. You can edit your make file, again, ooh, scary, and do things like, okay, well, here's check. So what does the check command do? Well, it goes into this testing directory, or it says run make on whatever's in the testing directory. So what's in the testing directory? This make file. All right, so this stuff happens when you do make check. I want to, and I guess if you try it out, if you do make check, you will see that it just freezes. And that's because you haven't done anything with the command interpreter yet, so it doesn't know what to do. It's just waiting forever for someone to do something. So make check's not what you want to do yet. So what I might do instead is I'm just going to make up a new label like bcheck. I'm going to put default, which means make sure you always compile all the code first. And again, lab 5 gives the full details. I don't want to do it in this video. And then here, we don't want to make anything in bcheck. All right, making's already done. We don't want to call another make file like this one does. We just want to say Java DB61B dot basic tests. So now if we type make bcheck, wrong directory, so that's in the testing directory, make bcheck, it will make sure everything's compiled. So if I do make bcheck, everything gets compiled, it runs, it fails. Let's go fix this, okay? So size, what should it be? Well, I don't know, maybe data.length. Don't tell Paul, but I'm giving away part of the project. So I'll do make bcheck again. It recompiles everything, and now we pass. Okay, my main piece of advice, the number one thing you should do is work your way through this list, and you'll notice that as it happens, it works its way up this hierarchy, and build tests as you go. You will save yourself so much heartache. I will personally come to your house and cut holes in your chairs or whatever thing you don't want me to do, if you even dare trying to debug by doing the following. Java DB61 command interpreter, and then trying to, that doesn't make any sense. Then I'll get really upset. But if you do this, and start trying to do, like, adding test commands, or even worse, trying to do it in the context of load students after you've done that. Obviously, it's not going to do anything now because you haven't written the command interpreter. But if you try and test through the DB61B UI, that's just a horrible plan. There's no reason to do that. You should really build unit tests that work directly on row, or work directly on table, or on database, and so forth. You should not rely on the command interpreter as part of your testing technique, all right? I mean, obviously later, once you're using command interpreter, you should, but for now, as we're building these core pieces of the system, we should stick to unit tests. So after you're done with row, what's next? Well, next we'll come up to table. And in that case, I'm not going to go into a lot of detail with that, except to say the following, which is that table is an awfully complicated class. It does a lot of stuff. So you see that we have we start from, the constructor, and then all the way through down to the bottom, we do increasingly complex things. And you can more or less work your way forwards, writing unit tests. Though I guess I would be careful that you only really need to build anything that involves creating a new table, adding rows and printing, and then move on to database, and then fill in other stuff in table as you go. And I'm not going to spell out exactly what methods for you, but I will say that roughly speaking, you can work your way down. Another issue that I should bring up here that is sure to confound you a little bit is the notion of what a column is, okay? So it's very intuitive that a table contains rows, okay? What is a table but rows, right? Now, you'll note that a row is not an array of columns, it's an array of strings, okay? And that is because a column serves a different purpose than an abstraction for a piece of data. We already have something that's perfectly good. I guess the thing I've never said in this video, but is in the spec, is that your table, it's all string pieces of data. You can't store numbers in the tables. It's always strings. So if we're storing strings, strings is a great way to store a string. There's no need to make some special abstraction. So what is a capital C column? Well, I'm not going to read it in detail now, but be aware that a column acts as an index to a specific column, right? And this will come later, right? More when you get to phase 2, but be aware that columns are a little trickier than you might have suspected. So when you're working on table, at least, you won't have to deal with the column class for a while. In fact, let's see. Yes, I think you'll have a good long time before an actual capital C column rears its ugly head. Print. Yeah, you can get all the way up to here. I'm just doing this in real time. It's been a while. Yeah, it's only when you get down here that you have to start actually using the column class. So on phase 1, you shouldn't need to use the column class. Even though the word column appears here, right? It's not a capital C column. Okay, so I hope that what we've done so far has given you a sense that this is a surmountable challenge. Definitely stick to the phase 1 stuff, steps 1 through 6, and then at that point you'll be able to work on to selection and table sorting or searching, and most likely I'll try and get another video out on that. If not, I'll at least augment the Project 1 checklist with information that will be helpful for you for that. All right, there's a jet outside. I guess that's the cue to end the video. Ta-ta.